Hi, welcome back. So we're in Chapter 5, Prediction by Probability, the outline of univariate concept of probability. In particular, we're going to actually start with the probability of a discrete value. Since we are talking about random variables, imagine this x sub k, for example, I would say. Since it is a discrete, it could be outcome of 1, outcome of 2, or maybe outcome of 3, etc. We would like to find out what is the probability that particular outcome, for example, 2 that had happened. And this is sort of a prediction, in my opinion, rather than just analysis, because you are predicting something. You are giving a probability of a certain outcome to occur among other outcome. Coin have two possible outcomes, either head or maybe tail. In this case, if you toss the coin like as an experiment 5 different times, each time there are 2 possible outcomes. To find out the entire possible space, 2 outcomes and 5 trials that I have done, that will lead you to the possible outcome of 32 of these pairs. Assuming the normality of uniform for each one of them, it means each one of them have the probability to happen 1 out of 32. And since the random variable is a function, we can talk about its range, shows by actually what's so-called range of x, something like that. In the above example, head or tail, imagine you toss a coin 400 times, okay? And I assume that x has the number of heads. So what is the range of x? In 100 times, I could have observed the head 0 times, or maybe I could have observed 1 time, or maybe 2 times, and all the way 100 times. Just another example. Again, you have a coin, and imagine you toss the coin until the first head just appear. Let's use y here as the total number of coins has been tossed. The question is, how many times shall I keep doing that? What is the range of y? Well, the range of y, perhaps I toss the coin and the first time I've got to see the head, or maybe after 2 times, or maybe after 3 times. And this list can go on and on. Now, it is the time to discuss about something called probability mass function, or the PMF. If x is a discrete random variable, as we have seen an example before, then its range, which is the range of x here, is a countable set because it is a discrete random variable. And usually what we are interested in knowing, actually, it's the probability of x is equal to some x of sub k, such that k could be equal 1 or 2 or 3 whatsoever. This is an event shown by the use of the probability mass function. Probability mass function is a probability, gives us the probability of a possible value for random variable to happen. Let's say, for example, you toss fair coin twice, okay? Variable x represents the number of heads. One to find is the range of x, as well as maybe we can also find the probability mass function of p of x. Now, first of all, let's go ahead and construct a sample space. What is the range of x? Observation of the case to have head. Well, from here, I could have observed 0 head, I could have observed 1 head, I could have observed 2 head. What is the probability mass function? Well, how many times we could have seen no head at all? It happens to be only 1 time, so it is 1 over 4. How about the probability of x actually happens to be 2? It means it's 1 out of 4. How about the probability x happens to be 1? It is actually 2 out of 4. These are the probability mass function for each possible outcome. Now, if you would like also to use graph presentation for the probability mass function, it's easy to imagine. Well, you could have 2 axes where the first axis present the possible outcome, and this represent the probability. This is another way of actually graphing the probability distribution. Now, for discrete random variables, the probability mass function, or PMF, is also called probability distribution. Thus, when we ask actually to find the probability distribution of a discrete random variables, we can do this by finding the probability mass function. Now, based on this information, let's go ahead and build up quite a bit more intuitive idea. For that reason, say, for example, you have unfair coin. In this case, I would assume the probability of head, letter P. P could be any number. It could be 0.5, 0.6, 0.7, whatever, right? Where P here larger than 0 and less than 1. Let's assume that Y here, it's the total number of coin has been toasted. So one find the distribution of y. Distribution means the probability mass function of y. Okay, how to approach this problem? I am tossing a coin until I see head. Let's define the range of y first of all. Well, it could be 1 time, could be 2 time, could be 3 time, and so on. If I want to find the probability mass function, py, of having wine, is going to be exactly p. Why? Think about it, it's going to be exactly head. So this edge have actually the probability that we saw here going to be equal to p. How about the probability y is equal to? In this case, this would look like, first of all, I got tail, I didn't see head, and then I got head. What is the probability of this? The probability of tail is going to be 1 minus the p, is the complement of that. So in this case, got here the probability mass function of 2, this multiplied by this, we got this and this. How about probability y is equal to 3? Well, the space would look like exactly tail, and then I got tail, and then I got head. It's going to be 1 minus p multiplied by 1 minus p, and then by p, and so on and so forth. You got the idea. You will discover that the probability of y is equal to a certain value of y. It could be written in the form of 1 minus p to the power of y minus 1 multiplied by p. This can be known as a probability mass function in this particular case. Maybe we can just have a look at something called independent random variables. Now, in real life, we usually need to deal with more than one random variable. X and y are independent if the probability, we said that before, of x is equal to a certain x and y is equal to a certain outcome of y is equal, actually the probability of x is equal x. It will be multiplied by the probability of y is equal y. Actually, we have seen that before from the set theory. Let's say, for example, toss the coin twice, and let's define x here to be the number of heads you observe. Then you toss the coin 2 more times. You define y in this case to be again the number of heads you observe in this time. Now, what we want to find actually the probability of x less than 2 and y maybe larger than 1. This one is going to be the probability of x be less than 2 multiplied by the probability of y larger than 1. And by the way, we know possible outcome here. It could be 0, it could be 1, it could be 2. What's the probability here? Being less than 2, it means it could be 1 or 0. That is multiplied by what is the probability being larger than 1? It means only 1. This had to be 2. So the total then will be 3 over 16. Now we are ready actually to start talking about special kind of distribution using the probability mass function. That's exactly what we're going to do next. I will see you then.